AB Calculus homework help. This is an assignment I gave over this long weekend. It has to do with continuity, determining, and verifying, articulating. And here we have in this case determine. It says of means if the function is continuous or discontinuous at a given number, and justify your answers. And we did 4 and 5 in class. I assigned these next problems, both these 6s, the 7, 8, and 9, and I'm going to work out a couple of these problems, problems 7 and 8. And we're going to determine at the given number. Well, first of all, for this one here, we look at the 3 conditions. 1, f of in this case 1 exists, question mark. Well, we have our function, our piecewise function defined for x is less than 1, and also for 4 when x is greater than 1, but we do not see any of these things as greater than or equal to, do we? What that means is we do not have our function defined for x equals 1, and one of the things that we need is f of 1 in this case exists. So since f of 1 does not exist, f of x is discontinuous at x equals 1. That was pretty simple, but it's something you need to watch out for, and it's our first of our 3 conditions needed to make this thing happen for us. Okay. Next, let's look at problem 8. And I think I cut that out so it's more workable below. Here it is. Find C so that f of x is continuous for all real numbers. Well, we already know we have cx plus 1 when x is less than or equal to 3, and cx squared minus 1 when x is greater than 3. So we already know that the function is going to be defined at 3 in that we have this greater than or equal to, or the x is less than or equal to 3. So we know that part of it's going to be in play. The thing we need to find is the limit, or the limit left hand and right hand to equal each other. So we say limit as x approaches 3 from the left side of f of x equals limit as x approaches 3 from the right side of f of x. And then we're just going to write this out here. Left side is this one. We have cx. I'm just going to write cx plus 1. We'll substitute them later. And then cx squared minus 1. And now we're going to just substitute in 3. So c times 3 plus 1 equals c times 3 squared minus 1. And so we have 3c plus 1 equals 9c minus 1. And then we subtract we'll have all the variables on this side. So subtract 9c. And then if we subtract 1 from both sides, I'm going to continue to work to the right here. 3c minus 9c is negative 6c. And then on the right side, we have negative 1 minus 1. Negative 1, negative 2. Dividing by negative 6. We have c is equal to 1/3. And then we could plug back in if we need to, right? So we should get the left side here. Well, what is that value going to be if we plug in 1/3 for c? We're going to have 3. Let's see, we have 1/3 times 3, which is 1 plus 1. We're going to have 2. And if we plug in c here, we're going to have 3 squared. We're going to have c is 1/3 times 9 is 3. 3 minus 1 is 2. So we'll have 2 equals 2. So that's going to be our answer. And really, we're not asked to really justify here. That's sort of a separate problem. Let's see. Okay, well, that's it. Good luck. And as always, thanks for viewing.